Okay, here we go. Let's start a new chapter today. This is called Linear Inequations, a very easy chapter again. I'll quickly tell you what a linear inequation is going to be. Keep in mind that this is going to be a question from part A, which is compulsory, so it's best that you pay attention and work with it. So let us try and understand the meaning of linear first. The meaning of linear indicates that the power of the variable or the degree is 1, which indicates that anything that has just x or say a y all becomes a linear term. So I'm just going to take the first example. I'm going to take the example of x plus 3. X plus 3 is a linear polynomial, but when I say it is equal to say 4, then the equal to sign indicates that it is an equation, and since the degree of x is 1, this becomes a linear equation. Alright. However, if I replace the equal to with an inequality sign, which could be greater than, less than, greater than equal to, less than equal to, then it becomes an inequality sign. So if I replace all this in the equation like this, if I make it x plus 3 greater than 4, or if I make it say x plus 3 greater than equal to 4, then this indicates that all of this now becomes a linear inequation. Now let's take a simple example. Let us take an example where we have to solve a linear inequation. The linear inequation is x plus 3 greater than equal to 7. I have to solve this just like a linear equation problem. So I'm going to take 3 that side. When I take 3 that side, 3 is going to become minus 3. So it's going to be 7 minus 3, which is greater than equal to 4. So that's pretty much what your solution is. You're always going to read this as any value of x whose value is either equal to 4 or greater than 4. Remember, this is an inequality sign that has a greater than sign as well as that little dash underneath that. That little dash indicates that you will also have to take a value that is equal to 4. So you're going to read this as all values of x that are either equal to or greater than 4. However, had I just had something like x greater than 4, then you would have taken all values that are greater than 4. Alright, so the only difference between greater than equal to and greater than is, for greater than equal to, you also consider that value as well. So since it's greater than equal to 4, you will start from 4. Alright, now having said all of this, let us try and understand two very important properties of linear inequations. You will be using this quite a bit in the exercise. Today we're just going to solve about 9 problems from the exercise. So it isn't much because it's all about understanding the data. Let's look at the first property. If minus x is greater than minus y, then this implies that x is less than y. Alright, you have to change the inequality sign if you're cancelling off the minus on both sides. Let's take a very simple example. You know minus 4 is greater than minus 8, but when you get rid of the minus sign, 4 becomes less than 8. So that is what we are trying to say. If you're trying to eliminate the minus sign on both sides, please change the inequality sign. The same thing is true with fractions as well. If 1 by x is greater than 1 by y, this implies that x is less than y. I'm going to take a simple example again. We know that half is greater than 1/3. If half is greater than 1/3, it's very clear that 2 is less than 3. So if I flip both sides, it means that I also have to change the inequality sign. Please keep these two properties in mind. Please make a note of it so that we can start working on the problems. Just one last bit where I have to give you a bit of prerequisite just to tell you what the families of numbers are going to look like. I'm sure all of you know this already, but I'm just listing this down. You can make a note of it in your book. All natural numbers are numbers that start from 1. So these would be 1, 2, 3, etc. So I put that as a set. Whole numbers are denoted by W. They start from a 0. So it would be 0, 1, 2, 3, etc. Then I have integers. Integers are a combination of negative numbers, positive numbers, as well as 0. So they would start from minus infinity. So that's minus 2, minus 1, 0, 1, 2, etc. Mind you, none of the decimal numbers come here. Real numbers are pretty much all numbers that can be represented on a number line for you. So they could include natural numbers, whole numbers, integers, fractions, decimals, irrational numbers, rational numbers, pretty much all of them. As long as they're not complex numbers, they're all good to go and you can call them as real numbers. So in this chapter, we'll be focusing on all of them. So I'll directly start with the third problem in your exercise. The first two problems are just simple true or false. So in the first question, he says x belongs to n, which means x is a natural number. Alright, since x is a natural number, you only have to consider natural numbers as a part of your solution. You'll understand how to solve the first one. The first question is, solve for x when x belongs to natural numbers when 5x plus 3 is less than equal to 2x plus 18. My suggestion is, keep all your like terms together. So push your 2x near 5x and push your 3 near 18. So this is going to become 5x minus 2x is less than equal to 18 minus 3. You know 5x minus 2x is 3x, that is less than equal to 15. So I have x less than equal to 15 divided by 3. Solve this as a linear equation. So you get x less than equal to 5. Now you need to read this as all natural numbers that are either less than 5 or equal to 5. Can you list down all natural numbers that are less than 5 or equal to 5? That would be your solution set. You know natural numbers start from a 1. So I'm going to start by 1, 2, 3, 4. I also have to include a 5 because it's x less than equal to 5. So these would be all natural numbers that are either less than 5 or equal to 5. Alright, please pause this problem and try to do it on your own. They are very, very simple problems. Let's look at the second question now. The second question says 3x minus 2 is less than 19 minus 4x. I would do the usual things again. I'll move all my like terms together. So I get 3x plus 4x. Remember, there was a minus 4x this side. If I push it to the LHS, that becomes a plus 4x. I get 19 plus 2. I know this is 7x is less than 21. So x becomes less than equal to 21 by 7, which is 3. Remember, he's told us x belongs to natural numbers. So you read this as all natural numbers that are less than 3. You know natural numbers start from 1. And since it's less than 3, you do not include 3. Alright, so your answer is just going to be 1, 2. I'm just going to put that there. Do not include 3 because it's not less than equal to 3. Please pause this. Try to do this on your own. As in when you're getting clarity, please proceed with the rest of the problems. I have pretty much solved the entire exercise for you. You have a larger exercise coming up where you will be doing a lot on your own. Alright, let's go to the next one. In the fourth question, he says x belongs to whole numbers. So whole numbers, you know, start from a 0 and does not include any negative numbers. So let's look at the first question. The first question, I'm just going to put that up there. In the first question, he says it's x plus 7 less than equal to 11. And he's asking us to find the solution set of x. And he's told us that it is whole numbers. So all I'm going to do is push 7 that side. So I get x less than equal to 11 minus 7, which is 4. So your solution set would be all whole numbers that are equal to or less than 4. Whole numbers start from a 0. I have to go all the way to 4 because the inequation says it also includes 4. I've just circled the equal to sign so that you remember it. So this would be your solution set. It would be whole numbers, so it would be 0, 1, 2, 3 and 4. Now for the second one, it's a very simple problem. I want you to try that on your own. You can pause the video at this point in time. Just move the terms around and see if you're able to understand it. Alright, let's try the second one now if you haven't done that already. 3x minus 1 is greater than 8. So I'm just going to move that on the right hand side. So that's going to give me 8 plus 1. So 3x is greater than 9. This implies x is greater than 9 by 3, which is equal to 3. So my answer is just going to be x greater than 3. Can you think of all whole numbers that are greater than 3? Since they're greater than 3, I cannot include 3. So I need to start with the next whole number, which is 4, 5, 6, and it goes on till infinity. So you're basically listing down all whole numbers that are greater than 3. That would be your solution set, and that's your final answer. All right. I hope this was clear to you. Most of the exercise is just going to revolve around this. So you just have to move terms around, find out what family of numbers it belongs to and write the solution set. Let's look at the third one. The third one might be slightly different for you. So I have 8 minus x greater than 5. So I'll decide to move 8 on the right hand side. You can also move x on the right hand side if you want to, but I'll move 8. So I get minus x is greater than 5 minus 8. I get minus x is greater than minus 3. Now, if you recollect a property, if I have to cancel minus sign on both sides, remember it has to be cancelled on both sides, then I'm going to reverse the inequality sign. So this becomes x less than 3. Now, since this belongs to a family of whole numbers, can you think of all whole numbers that are less than 3? So your solution set, since it's a whole number, would start from 0. will go to 1 and then it will end at 2. I cannot include 3 because it is just less than 3 and not less than equal to 3. I hope this is making sense to all of you. If you have more questions, please list it down in the comment box so that we can answer it. Let's look at the fourth question. The fourth question says, a very simple question nonetheless, 7 minus 3x is greater than equal to minus half. Again, you could either push x on the right hand side or leave x on this side. You're pretty much going to get the same thing. I've just made a slight change here. I've decided to push x to the right and push half to the left. So when I take the LCM on the LHS, I get 15 by 2. 15 by 2 greater than equal to 3x, or 15 greater than equal to 6x. So I'm going to bring the 6 down there. So it's going to become 15 by 6, sorry, is greater than equal to x. So I'm just going to put that up there again. 15 by 6 is greater than equal to x. I'll see if I can cancel off something on the LHS. I know it goes by 3. So I get 5 by 2 is greater than equal to x. Now I generally don't like to put x on the right hand side, so I'll keep x on the left hand side, but don't change the inequality sign in any way. Remember, the inequality is pointing towards x, so even when you move it around, make sure the inequality is still pointing towards x. You know, x is less than equal to 2.5 and it belongs to a whole number, so your solution set is going to be 0, 1 and 2. Remember, 2.5 is not a whole number, so I need to pretty much stop at 2. Alright, so please keep this in mind, that whenever you have, or whenever you're changing the LHS and RHS, you do not really change the meaning of the inequality. I want you to try the fifth and the sixth one on your own. They're actually very easy problems. In case you get a doubt, please go back and refer to the previous solutions and try doing it on your own. I've anyway done all the problems for you. You may pause this video at this time and follow all your steps. Alright, let us try and solve the fifth one first. I'm just going to put that problem up for you. It's x minus 3 by 2 less than 3 by 2 minus x. So I'll move all my like terms together. I'm going to move all the x terms together. So x plus x is going to be less than 3 by 2. I'm going to move another 3 by 2 on the right hand side. So that's going to give me 3 by 2 by 3 plus 3 by 2. X plus x is 2x is less than equal to 3 by 2 plus 3 by 2 is going to give me a 3. So I'm going to push the 2 down. So I'm going to get x is less than 3 by 2, which means x is less than 1.5. Now he's told us that everything belongs to whole numbers here. So think of all whole numbers that are less than 1.5, which is pretty much just going to be 0 and 1. Alright, so that is going to be your solution set. You can also write solution set x is equal to 0, 1 in flower brackets. Keep that in mind, that it's always important to know what family of numbers they belong to and how you interpret the final inequation. Writing an inequation in a statement format will also help you at this point in time. Alright, let's look at the sixth question. The sixth question is also very, very simple. I'm just going to put that up for you. 18 less than equal to 3x minus 2. Push the 2 to the left hand side. So I get 18 plus 2 is less than equal to 3x. I know 18 plus 2 is 20. I'm just going to put that up there. 20 is less than equal to 3x. Again, I do not like to keep my x on the right hand side, so I'm going to keep x on my left hand side, but make sure your inequality is pointing towards 20 like the way it was in the previous step. So I get x greater than equal to 20 by 3, which is 6.66. So my inequation actually is x greater than equal to 6.66. So you're looking at all whole numbers that are greater than or equal to 6.66. You know, 6.66 is not a whole number. So your solution set is going to be 7, 8, 9 all the way to infinity. Please pause this video at this point in time. If you have any questions, please ask. Otherwise, I would like to believe that these are very simple concepts. Let's move to the fifth one. I want you to try the fifth one on your own. I've anyway put in the solution for you, but unless you try it on your own, you will not be able to understand it too well. So this is 3 minus 2x is greater than equal to x minus 12, and he's told us that x belongs to natural numbers. So I want you to completely try this on your own. Please pause this video at this time and finish the problem. Remember, x belongs to natural numbers which starts with 1. So I'm solving this for you if you haven't done this already. I have 3 plus 12 is greater than equal to x plus 2x. So I get 3x is less than equal to 15. Remember the pointed edge of the inequality is towards 3x. So I get x less than equal to 5. So think of all natural numbers that are less than or equal to 5, which would be 1. They belong to natural numbers, so that would be 1, 2, 3, 4 and 5, because I have a less than and an equal to sign in the inequality. So this would pretty much be your fifth question. By now you would have probably realized it's quite simple. Let's attempt the sixth one. Sixth one is also something that you can try definitely for sure. As soon as I put in the problem, I want you to attempt it on your own. Please pause the video and try it. I have 25 minus 4x is less than equal to 16. This is a very simple problem. Please go ahead and do it. He's told us that x belongs to R and he's asked us to find the smallest value possible. X belongs to R indicates that R is a real number, and I hope you all remember that real numbers are those numbers that you can put on a number line. So let us see how we can start with this problem. I have 25 minus 16 is less than equal to 4x. I have moved 4x to the right hand side, 16 to the LHS. I know 25 minus 16 is 9. 9 is less than equal to 4x. So I have 4x is greater than equal to 9. So x becomes greater than equal to 9 by 4. We know 9 by 4 is 2.25. Now let me just pause the video at this point and tell you that he's asking us to find the smallest value of x. Now if you notice, I have x is greater than equal to 2.25 and he's told us that x belongs to R. If x is greater than equal to 2.25, then it means that the smallest value x can take is either 2.25 or any number greater than 2.25, which ideally means the smallest number must be 2.25, right? And we know 2.25 is a real number. So when x belongs to R, the smallest value of x is going to be 2.25. All right. The largest number it can take is obviously infinity. Now let us also understand if the same question were to be given in a very different way. If he tells us that x belongs to z, which is integers, let us find out what really happens. We have already got x to be greater than equal to 2.25. Now the smallest real number value it can take is 2.25, but 2.25 is unfortunately not an integer. But we also know that 2.25 lies between integers 2 and 3. All right, but your value of x must be greater than 2.25, which means the next possible integer that you can possibly get is only 3, because 2 becomes less than 2.25, which does not satisfy your inequation. So x equal to 3 will be the smallest integer that x can take. All right. If they had asked you the same question in terms of natural numbers, your answer would have still been 3. Even for whole numbers, your value would have still been 3. All right. So these are the type of questions you'll have to be a little careful on. If he tells you that it belongs to z, and if you get a decimal number, and if you get something like this where x is greater than equal to 2.25, then the next integer that you get after 2.25, which is 3, is going to be your answer. All right. Please pause the video and try to do this on your own. All right. Let's look at the seventh question. In the seventh question, he says x belongs to R, so it's a real number. Let's look at the first question that he's put up for us. He's told us that minus 4x is greater than equal to minus 16. So I have a minus sign on both sides, which I have to cancel off. But mind you, when you cancel off minus sign on both sides, you have to change the inequality sign. So 4x becomes less than equal to 16. When I push 4 that side, I get x less than equal to 4. Now think of all real numbers that are less than equal to 4. There are so many real numbers that are less than equal to 4. So in this case, you have to write it in a set builder notation, which says x such that x belongs to R and x less than equal to 4. So whatever I've written in blue is what your final answer is going to be, because you can't really write this as a solution set in terms of numbers, because real numbers will be infinitely many between, which are less than equal to 4. So you just write it in that format. Let's look at the next question. 8 minus 3x is less than equal to 20. I want you to try this on your own. Remember, your final answer whenever x belongs to R should be written in the blue format. Whenever they say it's either an integer or a natural number or a whole number, you'll have to actually put the numbers in the flower bracket like the way we've been doing before. All right. I also want you to do 3 and 4. They're very, very easy. Please try them, and I want you to put your final answer just like the way we have put it for the first one. You can pause the video at this time. Alright, if you're finished solving it, I'll solve it for you as well. Let's start from the second question. The second question is quite simple. We're just going to put that up now. So it says 8 minus 3x is less than equal to 20. So as usual, I'll move all my terms. So I get 3x is less than equal to 8 minus 20. I know 8 minus 20 is minus 12 is less than equal to 3x. So I like to keep my 3x on the right hand side. Remember, the pointed edge is towards minus 12. So eventually I'll get x is greater than or equal to minus 4. Please put this in set builder format because it belongs to R, it belongs to real numbers. So you're just going to say x such that x belongs to R, x greater than or equal to minus 4. It basically tells you that it's any real number that is either equal to minus 4 or any real number that is greater than minus 4. Let's look at the third question. It says 5 plus x by 4 is greater than x by 5 plus 9. As usual, I'm going to move all my x terms together. So I'm going to get x by 4 minus x by 5 is equal to 9 minus is greater than 9 minus 5. I'm going to take LCM on the left hand side. So I'm going to get 5x minus 4x by 20 is greater than 4. I know 5x minus 4x is equal to x, so x by 20 is greater than 4. Move the 20 that side, I get x greater than 20 times 4, which is 80. So you're basically looking at all real numbers that are greater than 80. So my answer is going to be x such that x belongs to R, x greater than 80. I hope this was clear to you. This is pretty much what you would be doing in this exercise. Just move around the terms, get a final inequation and put the solution set to it depending on what family of numbers it belongs to. When it belongs to real numbers, it's probably easier because you don't have to write the entire thing. You just write it in a set builder notation like this. Let us look at the next one if you haven't done that already. If you haven't, please pause at this point and finish the problem off. I have x plus 3 by 8 is less than x minus 3 by 5. Please cross multiply, take 5 on top, take 8 on top on either side. So I get 5x plus 15 is less than 8x minus 24. Move around the terms. You can choose to move around the way you want it. So I'll move 5x on the right hand side and minus 24 to left hand side. So I get 15 plus 24 is less than 8x plus 5x. I know 15 plus 24 is 39. So I get 39 less than 13x. So I want to put my x to the left hand side, so I get 13x greater than 39. You know 39 goes 3 times in x, so I have x greater than 3. So think of all real numbers that are less than 3. Since they are in real numbers, you know what format they have to go in. X such that x belongs to R, x greater than 3. That's pretty much what we're doing. I hope this is quite simple as well. All right. So let's move into a few more problems now. Keep in mind that when it belongs to integers or integers or natural numbers or whole numbers, you have to write the numbers inside the flower brackets. The eighth one is also something you can try. It's a very, very simple problem. Please pause the video at this time, finish the problem and verify your answer. Please understand what family of numbers it belongs to. Move around the inequation terms everywhere. Whenever there's a minus sign, you're cancelling on both sides, then make sure you're changing the inequality sign. Otherwise, do not change the inequality sign. Okay, time for you to verify your steps. Let's put in the problem. I have 5 minus 2x is less than 5.5 minus 5 by 3x. The first thing I have to do is convert that 5.5 into an improper fraction. So I get 5 minus 2x is less than, that becomes 11 by 2 minus 5 by 3x. Now move all your like terms together, keep them handy so that it becomes a little more easy for you to work with. So I get 5 minus 11 by 2 is equal to minus 5 by 3x plus 2x. Take the LCM on both sides. I get 2 as the LCM this side, so I get minus half is less than, take 3 as your LCM here, you get minus 5x plus 6x. So when you solve it, let's go back, I have minus half, okay. So I'm just going to put a minus half there, is less than equal to, I have an x by 3. So I'm just going to move the term there. So I get x by 3 is greater than minus half. Please bear in mind that you should not change the inequality sign here. So I have x is greater than minus 3 by 2. Now since x is greater than minus 3 by 2, I know minus 3 by 2 is minus 1.5. So now that you know what family of numbers it belongs to, they're asking you to find the smallest value of x. The smallest value of x will be minus 1, because you're looking at all integers which are greater than minus 1.5, and you know your integers are always going to be those numbers that are either positive or negative with a 0. So if you are going to look at all values of x that are greater than minus 1.5, the smallest integer is going to be minus 1, because minus 2 is not going to be greater than minus 1.5. So your answer is minus 1. So minus 1 would be your smallest value. All right. I hope this made sense to you. If this has not made sense to you, please let us know. We'll be able to clarify this again. All right. Finally, the last question for the day. We have to find the largest value of x for which 2 times x minus 1 is less than 9 minus x, and he's told us that x belongs to whole numbers here. Since x belongs to whole numbers, I want you to try this. This is very easy. All you have to do is open the bracket and try. I'm just going to make you pause the video at this point in time and proceed. All right, let's start solving it. I'll solve it for you and you can just check. So just open the bracket on the left hand side. So I get 2x minus 2 is less than equal to 9 minus x. Move the terms around. So I get 3x is less than equal to 11. So I have x less than equal to 11 by 3. You know 11 by 3 is 3.67. So think of all whole numbers that are less than equal to 3.67. I know whole numbers start from a 0. 3.66 is not a whole number. So think of all whole numbers that are less than 3.66, which would just be 0, 1, 2 and 3. I hope you were able to understand most of it today. Today was just an introductory class. In the second exercise and a few more problems that are left in this exercise, I expect you to solve more. But until then, have a good day. Bye-bye.